Welcome everyone in lecture number 30. In this video lecture, I will discuss some more problems on applications of Fourier sine and cosine transforms to solve boundary value problem. In my last lecture, I have solved one of the boundary value problem. Here I'll solve two more boundary value problems. So first problem is on the screen that you can see. The problem is the temperature U in the semi-infinite rod is determined by equation del U by del T is equal to K del 2U over del X square, subject to the condition U is equal to 0 when T is equal to 0, X is greater than or equal to 0, and del U by del X is equal to minus mu, where mu is a constant, when X is equal to 0 and T is greater than 0. That means the meaning of first condition is that the temperature is 0 when time is 0 and X is greater than or equal to 0, means initially the temperature is 0 in the rod. Okay, and the meaning of second condition is that del U by del X is equal to minus mu when X is equal to 0 and T is greater than 0, means as you increase the time, the rate of as you increase the time, X is equal to 0 means at the end, at the boundary of the rod, the temperature, rate of change of temperature is minus mu, which is constant. The temperature is constant at the initial. जैसे ये rod है अगर, if you have this rod and this denotes X is equal to 0, okay, point, then at this end, the temperature, rate of change of temperature is given by minus mu. Del U by del X is equal to minus mu. Rate of change of temperature is constant here. So how to solve this? We are given actually this condition. Del U by del X is equal to minus mu. So we apply here Fourier cosine transform, as I have discussed in my lecture number 29. So whenever we are given derivative condition, we apply Fourier cosine transform. So we apply Fourier cosine transform on the given equation del U by del T K del 2U over del X square. So Fourier cosine transform is 0 to infinity del U by del T cos px dx is equal to integration 0 to infinity K del 2U over del X square cos px dx. By the definition of Fourier cosine transform. Okay. Now, as you can see, this integral is with respect to x. So we can take this derivative outside in the form of d over dt. D over dt 0 to infinity uxt cos px dx. And on the right hand side we can take k outside the integration and then we integrate that. So It is our first function and this is our second function. So we have first function into integration of second function. So we have del u by del x cos px 0 to infinity limit on this minus integration del u by del x and differentiation of this minus p sine px dx. Okay, so this whole expression can be denoted by u c bar. So we can write this as duc bar over dt minus k, because at upper limit this is 0, at lower limit this will be uh, del u by del x at the value at del u by del x at the point 0 comma t. Okay, because u is a function of x comma t, so del u over del x is also a function of x comma t. So at lower limit means the value of del u by del x at x is equal to 0 comma t, plus because of this negative sign and this negative sign we have positive sign, k into p, this k will multiply with this expression also, and we have integration del u by del x into sine of px dx. So we have duc bar over dt is equal to k. This is given to you as del u by del x as minus mu when x is equal to 0 and t is greater than 0. So we can replace this by minus mu. So when we replace this by minus mu, this minus and this minus will make positive sign here, and we have only mu plus kp. We again take this as first function and this as second function. So we have u x comma t sine of px first function. Integration of this will be u into limit 0 to infinity, and then integration u x comma t, and differentiation of sine is p cos px dx. K mu plus, at upper limit this will be 0, because we suppose that as x approaches infinity u approaches to 0. Okay, and at lower limit this will be automatically 0. So we have this expression only. So we have um, this is when you take p outside, this will be 0 to infinity ux comma t cos px dx. So this is nothing but Fourier cosine transform of the function u. So this integration can be replaced by u bar uc bar. Okay, so we can write duc bar over dt k mu plus kp square mu c bar. So we have this differential equation which you arrange, you will get duc bar over dt minus kp square uc bar k mu. So this is a linear differential equation type whose general form is dy over dx plus p by is equal to q, where p and q are the functions of x. So we have in place of y we have uc bar, and in place of x we have t, and this is p, and here k mu is q, and both are uh, constants. They may be constants also. So we will find the integrating factor. Integrating factor is e raised to the power uh, mm, here we have negative sign. Let make me correction. Okay, so here we have negative sign minus kp square mu c bar. So that we have positive sign here. So kp square dt. Okay, and this value is e raised power kp square t. So the solution of above equation is linear differential equation is integrating factor into u c bar. Since uc bar is a function of p comma t, because it is a Fourier transformed function. So after taking the Fourier cosine or sine transform, we always get the function of p. That's why x is replaced by p here. And integration q, which is k into mu, this is q, and integrating factor is kp square t dt plus c. K mu e raised power kp square t whole divided by kp square plus c. So the value of mu c p comma t is mu over p square. This exponential will cancel with this, and plus c with multiplied with minus kp square t. Mark this as equation number 1. Now we need to find the constant value c. For that we use this condition. Okay, we are given that u is equal to 0 when t is equal to 0, means u x comma t is 0 when t is equal to 0. तो आपके पास u c बार p कॉमा t है, तो हम क्या करेंगे कि इसका फोरियर कोसाइन ट्रांसफॉर्म लेंगे. फोरियर कोसाइन transform of this equation, this condition basically. So we have integration 0 to infinity u x comma t cos p x dx is equal to 0. We put t is equal to 0 here, we replace t by 0 here. U x comma 0, so that we need not to write again and again when t is equal to 0. Okay, so we have done this, we have replaced t by 0. Now this whole can be represented by u c bar p comma 0. Okay, and this is equal to 0. So we have this condition. So substituting this condition, this in equation 1. Equation 1 क्या है? U C P T is equal to this. Okay. So we put U C bar P, we put T is equal to 0 there, so that we have on the right hand side we have only mu upon P square plus C. And this is equal to 0 because of this condition. U C bar P 0 is 0. So we put is equal to 0, so that the value of C is P square. इसकी वैल्यू ये आ जाएगी. अब ये वैल्यू हम इस इक्वेशन में सब्स्टिट्यूट कर सकते हैं इक्वेशन नंबर 1 में. So from equation 1 we get mu C bar P comma T is equal to mu upon P square plus C की जगह हम इसकी वैल्यू सब्स्टिट्यूट करेंगे, तो we use the negative sign mu upon P square and e to the power minus kp square t. So we can take mu upon P square common. We have this. Now this is the value of mu C bar, which is the Fourier cosine transform of u x comma t. To find u x comma t, we need to take Fourier cosine inverse of this. So u x comma t is Fourier cosine inverse of this function, which is the function of p. Okay. So by definition of inverse Fourier transform is equal to 2 upon pi 0 to infinity mu upon p square into 1 minus e to the power minus k p square t into cos p x dp. Generally, when we take Fourier cosine inverse transform or sine inverse transform, we always get some complicated expression inside the integration. You can see here that both of these we have functions of p, and doing the integration of this expression is not so easy. So generally, we leave such expressions as it is by taking constant terms outside the integration if it is applicable. So we leave this expression as it is, and this will be the answer for the given problem. Okay. So now let's do the second example. solve del u by del t is equal to del 2u over del x square, where x is greater than 0, t is greater than 0, such that we have u x 0 comma t is equal to 0, and u x comma t is bounded, and u x comma 0 is x for x lying between 0 to L, and 0 for x greater than L. So we are given u x 0 comma t, which means del u by del x at 0 comma t is 0. It's me. So we are given the derivative condition. So we apply Fourier cosine transform over this. Applying Fourier cosine transform on del u by del t del 2u over del x square. We get 0 to infinity del u by del t cos px 0 to infinity del 2u over del x square cos px dx. Again, we take this del over dt outside so that we have d over dt of integral u cos px dx. And here we have del u by del x cos px minus del u by del x p sin px dx. This is nothing but duc bar over dt. This is 0 at upper limit, and at lower limit this is minus del u by del x at 0 comma t plus, again we integrate this 0 to infinity del u by del x sin px dx. We are given the derivative condition del u by del x at 0 comma t is 0. Okay, and also you should write that we are assuming that del u by del x approaches to 0 as x approaches to infinity. You should write this somewhere. Okay, don't write it directly, otherwise it will make confusion. So I should write here, since we assume that del u by del x approaches to 0 as x approaches to infinity. Okay. So this is 0 because we are given that this value is 0. So we have 0 plus this. So we solve this now. This is equal to P integral 0 to infinity del u by del x sin px dx. Okay. यहाँ पे इसका भी रीजन हम लिख देते हैं because del u by del x is 0 at x is equal to 0. We have duc bar over dt is equal to p u sin px minus p u cos px dx. Again, assuming that u approaches to 0 as x approaches to infinity, and at lower limit this will be 0, and we have p square. This is nothing but uc bar. Okay. This expression vanishes. This is 0. We are left with this, where p into p is p square, and this integration of u cos px is denoted by, it is the Fourier cosine transform of the function u. Its short form is uc bar. Okay. So we have duc bar over uc bar. We can separate the variables, the variable separable differential equation. Integrating this is variable separable differential equation. So integrating it, we get log of uc bar minus p squared t plus log of c, so that we have uc bar log of uc bar minus log of c. So log of uc bar over c, this implies uc bar over c is equal to e to the power minus p squared t. This implies uc bar is equal to c to the power minus p squared t. Now we write it in this form. So to find the value of c, we put t is equal to 0. We get Fourier sine transform of ux comma 0 is equal to c. आपको क्वेश्चन में ये कंडीशन गिवन है, this one, ux comma 0 is x. So we'll take the Fourier cosine transform of this condition. Okay. Taking, let me write the expression first. Since ux comma 0 is x for x lying between 0 to L, for simplification, let's replace L by 1. Okay. Let us replace this by 1. So, and 0 for x greater than 1. So, taking Fourier cosine transform of this condition, we get integration 0 to infinity ux comma 0 cos px dx is equal to, we split this limit into 0 to 1 and replace ux 0 by x cos px, and for 1 to infinity we have 0 cos px dx. So this expression is 0. When you solve this, you will get first function integration of second function, which is sine px over p, and then we have minus sign, differentiation of this, and integration of this again, which is negative. So we have positive sign cos px over p square. Applying the limit 0 to 1, so that we have sine p over p. This left hand side is denoted by fc of u x comma 0. Okay, so we have fc u x comma 0 is equal to sine p over p, sine p over p plus cos p over p square cos p over p square. At lower limit this will be 0 and this will be minus 1 upon p square. So we have sine p over p into, sorry, plus cos p minus 1 over p square. So we come to this condition. We have obtained this solution. This is the value of c that we obtained. So from equation number 2, substituting value of fcu comma zx comma 0 in equation number, ये इक्वेशन नंबर 2 है, यहाँ पे हम इसकी वैल्यू सब्स्टिट्यूट करेंगे तो c की वैल्यू हमें मिल जाएगी. We get c is equal to sine p over p plus cos p minus 1 over p square. Okay. Now substituting the value of c in equation number 1, we get value of Fourier cosine transform of u x comma t. This is equation number 1. This one is equal to sine p over p plus cos p minus 1 over p square into e raised power minus p square t. Now we'll take the Fourier cosine inverse of this whole expression to get the value of ux comma t. Okay, ux comma t is nothing but Fourier cosine inverse of this whole expression. Okay, so ux comma t is 2 upon pi integral 0 to infinity sine p over p plus cos p minus 1 over p square e raised power minus p square t cos px dt. We leave it here. This is the answer because it can't be solved further. It is very difficult to solve it. So we generally leave at this point after taking the inverse transform. Okay. So I hope you understand both examples and the reason behind why we are applying Fourier cosine transform in these two questions. Okay. So you can try some more problems for your practice. And if you are feeling any problem in any question, you can ask me. Thank you very much for watching the video. If you like my video, please press the like button and share it. And also you can subscribe my channel to get the notification of any other new video. Thank you so much.